This conference will now be recorded.
Hi friends, good evening. In this Business Intelligence Master Program, so in today's session, we are going to talk about Spark SQL joins and the Spark SQL functions. So we will try to understand some of the Spark SQL functions which are important, and we are also going to talk about Spark SQL joins. Joins are very important with respect to SQL, or you can say with respect to the Spark. Okay, you can do these joins in a SQL. Okay, Spark SQL with the help of temporary tables, or what else you can do is you can just to apply these joins with the directly data frames. So we will see with data frames how you can join two different data frames. Okay, what kind of joins we can able to do, all those things we will see. In today's session we will talk about read data frame, how to read a data frame. Then we will see derive column transformation. You remember in data flows we have something called derive column transformation, meaning we are adding the column. So in the same way, how to do this same transformation in Spark? Update column name transformation. Suppose I want to rename the column name. How you can rename this particular column? Next, drop column transformation. Suppose if I want to drop some of the columns, how you can drop? Concat function. If you want to concat two values, let's say I have Rama and Krishna, I want to add these two. So Rama Krishna I want to form. So meaning you need to concatenate Rama and Krishna words to get a Rama Krishna. How you can use concat function? Now concat underscore ws function. So ws is nothing but a first argument you need to give the delimiter. Delimiter means we have a Rama and a Krishna. So in between you need to say Rama is brother of Krishna, something like that. In middle I want to add some text. Rama is Krishna. Okay, so is I want to put in between Rama and Krishna, something like that. You are going to use something called concat underscore ws function to add that particular delimiter. Next, we are going to talk about when function. Suppose based on condition, I want to add some value. Okay, based on some condition, I want to add the values. Then we need to use something called when function. If you remember, if you know any language, right, we have something called if. So if conditions you will use, then you are going to use if condition is false, then you will go and check another condition in else if. So if else if is also untrue, that condition also failed, then you will go to the default block. In the same way, you are going to check multiple conditions. If none of the condition is true, you are going to execute some default block. So likewise, if you have some conditions to execute, you can use when function. Then we will talk about joins overview. Okay, so we will talk about joins. Then we are going to talk about inner join. We are going to talk about inner join. What is inner join, left join, right join, and the full join. Okay, these are the things we are going to learn in today's session. Okay, let's start with read data frame. Let's say, so how to create data frame? Spark dot create data frame. Okay, so these are my values. You see, one master cloud Pandit 978, one visa cloud Pandit 978, two master Rama 770, two visa Rama 1240. Likewise, see, all this is my data up to here. Here I have mentioned my column names: credit ID, credit type, credit name, credit score. So when I display this data, it will display something like this: credit ID, column, credit type, credit name, credit score, 4 columns. So first record is, you see, one master cloud Pandit 978, one master cloud Pandit 978. So your third record, you see, two master Rama 770, two master Rama 770. Okay, so in which order you have different, in same order it will display in a tabular format. Okay, results will come in a tabular format. This is how you can read the data now. So I want to add the extra column to that. Okay, how you can do that is df dot with column you need to use to add the column. Okay, with the column. So what is the column name? My column name is record underscore updated. My column name is record underscore updated. So what is the value? What is the value? Value is current underscore date I am giving. I am giving current underscore date. So what it means is, this is a column name. In that column, we need to populate the data. What data you are going to populate is today date, current date you will populate. Okay. So next, for this result, df underscore date. Okay. For that result, I am going to add one more column, printed underscore timestamp. Printed underscore timestamp is nothing but current underscore timestamp. See, this is a Spark SQL function which will give only date. But if you say current underscore timestamp, it is going to give you date and time. It is going to give you date and time. Both the things it will give. You understood, friends? It will give only date. It will give date and time. You see. Okay, you have these 4 columns are previous columns. Now I have added record underscore updated. You see record underscore updated, only date. Printed underscore timestamp, printed underscore timestamp, current timestamp, meaning date and time, date and time, date and time, date and time. Okay, so you may think this is not today date. Yes, not a today date, because whenever I prepared this documentation, that particular day that particular day data. Okay, understood. Now next, update column name transformation. How to update column name? You see, you have a column name called printed underscore timestamp. If you remember that particular printed underscore timestamp column, I want to rename to the record underscore inserted. You see, previously you are having printed underscore timestamp. Now I have renamed to the record underscore inserted. Okay, next, drop columns transformation. You see, we have a df underscore ts drop credit id. Okay, one column I have dropped. Next, so on this result, df underscore drop record underscore updated printed underscore timestamp, meaning the two records which I have, two columns which I have added by using with column plus credit id which is there in my source data frame. So total 3 columns I am dropping. So you will have a remaining 3 columns left. See, credit id I removed, I dropped. Remaining 2 columns, that is record underscore updated print underscore timestamp. Okay, whatever 2 columns you have added with column and whatever base column credit id we have, total 3 columns I am dropping. Okay, drop. You may ask why you are dropping 1 here, why you are dropping 2 here. So just to tell you that drop function can take a multiple columns or it can take a single column. If you want to drop all 3 columns at once, you just put comma here after credit id, say record underscore updated. Next put comma printed underscore timestamps. Like that you can able to add all the column names. Next, concat function. So concat function, what it will do, df underscore drop one, df underscore drop one. Okay, from that particular result, you see, I'll just tell you. Oh shit. Yeah, let me just display the result. It will be easy for you to understand. Okay, df underscore drop one dot with column. What with column will do? Can you tell me? With column will add the data. Okay, description. See, this is the description column. Okay, first description column is this. I'm just doing, see, drop one dot credit type comma drop one dot credit name, meaning credit type credit name both I am concatenating. This is a concat. Okay, master cloud pandit, visa cloud pandit, master rama, visa rama, master krishna, visa krishna. So these two words are concatenating, adding. You see concat credit type comma credit name, but you see there is no delimiter, master space cloud pandit, visa space cloud pandit. We need to have some space to get the more readability, to have a more readability, right? But we don't have that space. Now you see description in this concat df underscore drop one dot credit type comma lit. We have a space, meaning after printing credit type, you are giving the space, then you are printing the credit name, master space cloud pandit. You see in this next column which you have added, master space cloud pandit, visa space cloud pandit, master space ram. Understood? You are getting some space here. Lit of hyphen, if you have given, it will give master hyphen cloud pandit, visa hyphen cloud pandit, master hyphen rama. Like that it will give the result. Okay, clear?
Malaya, what is lit there? Means it is predefined function or what?
It's not a column, right? It's a literal constant value which you are passing in between the credit type and a credit name. Credit type is a column, credit name is a column, but this whatever space you are giving, this is a constant value, literal. Just to tell that you need to put that particular value inside a lit function.
Okay, okay, Malaya.
I just imported here from PySpark.SQL functions, import concat comma lit. Concat is also SQL function, PySpark SQL function. Lit is also PySpark SQL function. Okay, I just imported both. As I am not using here that constant value space, that's why I am not importing lit here. Okay, fine. Next, concat underscore ws. So in this function exactly work like how concat is working, but in this the definition, the syntax of concat underscore ws is little bit different. You see, concat underscore ws, this is the first one is a delimiter. Okay, you need, if you are giving space, okay, meaning whatever columns you are adding, if you are adding multiple columns, in between all those columns this particular delimiter will be applied. Now I am giving space, that space will be available between credit type and credit name. You see, credit type and credit name, you'll have a space. If you have given here hyphen will come. Whatever you have given first argument, that is a delimiter between the all columns which you are trying to concatenate. Let's say I am trying to say credit type, comma credit name, comma credit score. Then automatically master space cloud fund space 978 will come. Okay, this particular first argument, okay, first value space will be applied between all the columns which you have mentioned to concatenate. I am trying to concatenate credit type and credit name. So between these two columns, I will get this space. Clear? Next. Okay, so try to understand this when function because it is very, very important function. See here, very simple. Now what I wanted to do, let's say this is the data. Okay, this is the data. In this, what I'm doing, credit type equal to master. If the credit type is master, I want to give a 5% discount. See here, I'm with the column, I'm adding a discount column. This discount column values, I'm just calculating. How I am calculating, I'm putting some condition. When credit type is master, if the credit type is master, add a discount column. Okay, against discount column values, if the row is master, you put here 5%. If the row is master, put 5%. Okay, that is one. Second scenario, second case is when credit type is visa, put 6% discount. Okay, 6%, 6%. Otherwise, if the credit type is not master, not visa, just put none. Can you tell me against this what value I will get? Against this what value I will get? Against visa what value I will get? Against master what value I will get? Okay,
For visa, it should be added 6%. For master, it should be added 5%.
Yeah, fine, that's good. But can you tell me, is it a wrong or correct? Is it wrong or correct? Is it a correct or wrong? Tell me, friends. We know, right? It is wrong.
Only. Why
What?
it should be null?
Very good. Because remember, Python is a case sensitive. You see, master M is capital, S here also capital, but V is capital here, but here you have a small v. So this visa is not equal to this visa. So meaning this visa will go to the otherwise condition. That's why you are getting none, null values. Okay. So that I will give you more examples in the notebook. Now let's talk about joins. So joins, see, join basically tells you you have a two tables. Okay, between the tables, if you want to get the common records, okay, common records. Now you need to use something called inner join. Inner join will give the common records between the two tables. Left outer join will give the common records between the table 1 and table 2 plus, okay, common records between table 1 and table 2 plus all remaining records in the left table it will give you. All the remaining records in the left table it will give you. Understood, friends? See, common between table 1 and table 2, all remaining records in the left table. Right join means common records plus all remaining records in the right table. Okay, full outer join means everything from both the tables basically. Cross join means product. Each record in table 1 will go and join with all the records in table 2. So if you're not able to understand from this diagram, please keep an eye on this. Just remember there is a common here. Left means common plus something left. Right means common plus something right. Full means common plus full out, like full right, full left. But ultimately in all the scenarios, what is the common? Common records are the common things you are going to get. If you say left, apart from common you will get left. Okay, here common plus all the right you will get. Okay, let's see with example, you will have more clarity. Now you have inner join orders. Now I have a customers. Now I want to find a inner join. So when I join these two tables based on the customer ID, can you tell me who has placed what order? Do you have information? So my customer is just telling. So can you tell me whoever has placed the order from our organization? See, our customers are, these are the our customers. Can you just look at this table and see out of 1, 2, 3 who has placed the order? Only second person. So two
Customer
is,
ID. Yes.
yeah. So you need to join these two tables. So I will read the orders as a DF1. Customer table I will read it as a DF2. Okay, now df1 of customer ID is equal to df2 of customer ID. Meaning this column in the order table should be matched with this column in customer table. If both are equal, so here I want to get only inner records. Inner means only common record. Here you see, yeah, when you show you will get it, but you see 2 is here, 2 is here. So these are the matching records, isn't it? These are the common records. Now when you get the result, you will get only second record. You will get the only second record. You understood this? Oh, I think I explained all these things in data flows, right? Yes.
Yes, Malaya.
Yeah. This is in Spark. This is in Spark. Okay. So this is in Spark, inner join. Next, left to join means we have a orders table, we have a customer table. So you see here df1 dot join of df2. Here customer ID is equal to customer ID. It's a left. Left means, see, common records 2 and 2 here. These are the common records, plus 37 and 77 are the unmatched records. Okay, 37 and 77 are the unmatched record. Now you will get common records. See, 2 you are getting from both the tables, and orders records, all remaining orders you are getting, because it's a left to join. Left to means left to table, remaining records will get. You know, that's why I'll go a little bit fast now. Okay. Now right join. Right join means there's a order table, there's a customer table. So here you see, just you are putting here right. Okay, DF. Now you know here the matching records are 2 is the matching record, 3 and 1 are the unmatched records. 3 and 1 are the unmatched records. Okay. Now common record from both the table plus unmatched records from the right table I will get in my result. See, common record, this is a common record. Okay, so these are the like only records which are available in the right table. So there is no matching record in left table. That's a null it is shown. Let's go with the full join now. So full join means you have orders table, customer table. When you say here just a full, okay, df underscore full dot show. See here 2 is the common record, and 37 and 77 are the unmatched records. Here 1 and 3 are the unmatched records. So when you get this result, so 2 you will get, who is the common record, and here you will get only records which are available in left table, and you will get only records which are available in right table. There is no matching records here, null. There is no matching records here, so null. Okay, but full means everything will get. Next, we have a something called left semi join. What is left semi join? Let me just explain it quickly. So you have a orders table, customer table. So this is a extra thing that we have in Spark. Okay, left semi join means, first you try to understand. Left semi means left side columns only you will get it. Only left side columns only you will get. See, when I say simply left semi means left table columns only you will get in result. Right table columns you won't get. Plus what data you will get in your result is only common record. 2 is the common record, so you will get in result. You will get only, sorry, you will get in result only second record. You understood? left columns only you will get, left columns only you will get, left table columns only I'm getting, plus common records I'm getting. 2 is matching record, right? So matching a 2 laptop 1996, this particular record, it is displaying only from the left side. Right table columns, it will not display, left semi means. Okay. Yeah, these are the slides I have. Let's quickly execute these things in a Databricks. So for this, I already prepared all the code for you. So we quickly execute this and we will see whether all these things are working fine or not. Okay. Any questions before we go? Okay. So yeah. So Spark.create data frame. So you know, right? Let me just attach this notebook to the cluster. Okay. Let's run this. You see here, this is my DF1. This is my orders information. This is my order table. And let's say this is DF2. You know, right? How to create data. Okay, this is my data frame. Like this is basically what is this? This is customers data. Okay, this is a customer data. This is order data. Now I want to join these two. So how I am joining? You see df1 dot. So I'm just pinging something in chat window. Please look at this. Okay. 1 second, friends. Okay. Fine. So now you see here, this is a data frame one. Okay. So let's okay, meeting got cancelled. Okay, that's good. Let's execute it now. Okay. So let me execute DF1 now. Okay, this is my orders details. So I executed this data frame. This is having a customer's details. Now what I wanted to do, I want to join these two. How you want to join these two is in a different ways you can able to join. You see, df1 dot alias of A. So can you guess it and tell me what is meant by alias of A? Can you just guess it and tell me what is alias of A? Tell me.
It's data from alias.
Alias names. Okay, another name. Instead of calling it as a df1, I'm just calling it as a. Okay, next join. Okay, I want to join df1 with df2. So df2 name I am renaming as a b. Okay, next a dot customer id, meaning a table customer id column values should match with the b table customer id column. So once these are matched, I will get the common records, matching records. I may have a matching records, I may have an unmatched records. But when you say next, inner means you are saying if I want to see only common records in my result, I want to see only common records in my result. Let's execute it. You are saying here, what you are saying here, you are getting only common records. You are getting only common records. Now you may ask why I am saying 2 times customer ID. So the reason is this customer ID column is from the orders table. This customer ID column from the your customer table. Now what I want to do, I want to select only customer ID at once. So maybe in any table, from any table I want to select, then you need to use dot select. Let's say I want to get all the columns from the B table, then I want to get only few columns from the A table. A table is having only these 3, but out of this I just take order name. Then I just select a table order date. A table order date. If you want in a same order, then you just cut this, and then you just paste this here. Okay, now you see, first I just skipped this. Okay, from A table I'm selecting order name and order date, and from B table B dot star. Star means everything. Instead of giving everything, I'm just saying B dot star. Execute it now. See, you are getting order name, order date, customer ID, customer name, contact name, country. You are getting everything here. Okay, next, come here. From PySpark.SQL functions call. Call is the, yeah, here also I imported call. Call is nothing but a see. You need to tell it's a column. Customer ID is a column from a table. For that I can use the call function, but without using call function also it will work basically. But whenever you rename it, we will use this call. Okay, there are different syntaxes, but most widely used syntax is this is the syntax. Next, now I want to apply a, you see, I'll just remove these things as well for you, because let me just display everything for you first. Let's execute it. See, so left to join means common records place only records which are available in a left table. Only records which are available in a left table. You understood? Okay, clear friends? Now, okay, now what we will do, you can use a left, just you can say left, or you can say left underscore outer. Okay, same result. You can use left outer. Okay, you can use, you see here, left underscore outer, left, you use anything, you'll get the same result. Okay, you'll get the same result. Now you see, again I'm getting all these columns. This time I don't want to see this customer ID, because this customer ID is having more null values, and whatever this column is displaying too, that too I can able to see here itself. That's why this time A table all columns plus B table these 3 columns I want to select. Can you try to answer what I need to do here? Dot select. What I need to do, A dot star, isn't it? A dot star. You need to say B dot, B table customer name. B dot contact name. B dot country. can take all of this. You can say df underscore left dot show. Now you will see you'll get only customer ID column. You are not getting from the right table. This time you are getting customer ID column only from the left table. Okay, this is clear. From here you will come to know right side matching customer ID is 2 because this side data it is showing, right? So that's it. Next. Same, I hope you can able to understand. Right outer also you can simply say right, or you can say right underscore outer, right outer. Okay, see first I'll just comment this.
In above query, instead of selecting right table 3 columns, we can remove that whatever column is not required, that one.
Which columns is
That
not required?
above we are removing that customer ID in right table, right?
Yes, right.
Instead of selecting these 3 columns, we don't have any option to remove that particular customer ID column. If you are changing name customer ID as some other table name like alias,
Okay.
like that we can remove, right?
Customer ID column, if you rename, even though you rename, you don't require the customer ID column, because whatever value it is showing here, same value we have here. So if you want to look at what is the right table column value, let's say right table column customer ID value, if you want to see here, if you display customer ID here, if you say 2, that same 2 you can able to see, we can able to understand what is the right table customer ID value. We'll come to know here what is the point of renaming, or maybe you are saying you can rename it and you can include, or you can able to remove it, right? So that you can do it, but there is no use of including with renaming that particular column. Okay.
Okay.
You see here you have a right table. Okay, right join. I am doing right join. Right join means common records plus, see, common records. So here you can see there is a common record plus all remaining records from the right table I am getting. All remaining records from the right table I am getting. So when you say right records, you need to understand. You see here, so whatever value we have, whatever value customer ID we have 2 here, same value you can able to find it from the right table column as well. So that's why there is no need of including this customer ID column from the left table. So that's why what I will do, I'll just select A dot order ID, A dot order date, and B table all columns, and just select. Okay. Just execute. See, you are getting like left table customer ID column I just removed, and right table all columns, and left table remaining 2 columns I am displaying. This is the common record. Okay, these are the remaining records from the right table. Let's talk about full. You can say full, you can say full underscore outer, full outer, outer, and a full. In the same way, right underscore outer, right outer, you can say simply right. You can use anything. Now let's execute this. Okay, now you see, this is the common record. 1 and 3 are the only records which are available in a right table. Only records which are available in a right table. Now 37 and 77, the records which are only available in a left table. Only available in a left table. You understood joins? Everybody understood joins, friends?
Yes, Madam.
Okay. Now let me just show you left semi. I thought of showing you. Right? So left semi means only common record you will get. You see now, instead of full, I simply say left semi. Execute it. See, common record you are getting, and common record left table data. Left table is this. So if you say here df2, here if you say df1, execute it. This time left table is customer. So customer columns you are getting, customer table columns you are getting. That's how left semi will work. Okay. Fine. Let's display this data. Okay, so this is the data. This is the data I have. Okay, now, so in this data, first what I want to do, I want to add some extra column to it. So how to add df dot with column. So record underscore updated. I want to add a column called record underscore updated. So to that particular column, I want to get the data as a current underscore date. Let's see, current underscore date is today date is 20th. Okay, Jan 20, right? So 2021, Jan 20, 2021, Jan 20, 2021, Jan 20. Likewise, we'll get all these dates. Okay, now come here. So this result, I'm just taking this result. To this result, I am adding something called current underscore timestamp. Okay, I'm adding one more column called printed underscore timestamp. For this, I'm adding a current underscore timestamp. What it means? Date and time it will give. So what is this? 1409. Time is 7, right? 7:40. 1940 it has to say, but it is saying something like 1409 because it is in a UTC. It is in a UTC time. Okay. If you have any doubt, you can come here. You can say UTC. The 210. You understood? So we executed few seconds back. That's why it's a 29. Now, so you see record underscore updated, printed underscore timestamp. Now this printed underscore timestamp column, I want to rename as a record underscore inserted. Now you just see executed this column name is changed to record underscore inserted. How you are renaming this? How you are renaming these things? You are renaming these things with the help of a column
With
rename.
column.
Okay, with the column rename. With the column means it will add the column or it will modify the data for existing columns. With the column, you can use in a two places. One is for calculating the new values for the existing column. Second case is if you want to add the new column. Example, if this column is already available with some data. Now, when you say you are using same column and you are populating current underscore timestamp, whatever data you have previously doesn't matter. On this column, it will populate current date and time now. It will update that particular data. The column is already available. If the column is not available, anyhow, it will add this column and it will populate date and time. Okay, I just renamed this as a record underscore inserted. Now, df underscore drop. Okay, so this is the df underscore ts1, right? I am just taking df underscore ts. Df underscore ts means this one. In this, so in this we have a credit id, record updated, printed timestamp. You see credit id we have. Now what I'm doing, credit id column I'm remove it. See, you have still record updated, printed timestamp. This is the result, df underscore drop. Df underscore drop, df underscore drop. Drop, I want to drop few more columns. Record underscore updated, printed underscore timestamp. So I'm just mentioning these two columns. Now what will happen? These two columns also it will drop. Exclude this. See, these two columns also we have dropped. Okay, these two columns also we have dropped. You understood? So as we are dropping these two columns here, so we have a remaining columns like credit type, credit name, credit score. Okay. Next, PySpark.SQL. So this is basically concat function. Okay, I'm just applying the concat function. What concat function will do? What concat function will do? Concat function will concat those two values. Let's see, df underscore drop one. So in this, I'm just saying concat. I want to concat credit type and credit name, meaning master cloud and Visa cloud. You see the result? It is added the description column, master cloud, Visa cloud, something like that. It is there. Come down. I want to maintain some space. For that, I'm adding lit hyphen. Lit is a literal. So whatever constant value you want to include between credit type and credit name columns, you need to put that particular literal value inside lit function. Now you execute this and see. See, hyphen is coming in between. Now instead of hyphen, I want to put something called space. Just I want to put space. Let's execute this. See, you're getting space. Okay, I want to write something. Okay, master card is with Cloud Pandit. You see, this is the data I have written. Now you see, master card is with Cloud Pandit, Visa card is with Cloud Pandit, master card is with Ram. So some description column you can able to write it. Now come down here, you see concat underscore ws. What it will do? So credit type, credit name. So between these two columns, it will add this delimiter. Okay, let's see. Okay, master colon Cloud Pandit. Let's say here I'll just add the third column, that is credit score as well. Let's execute this. See, master colon Cloud Pandit colon 978. Okay, so instead of colon I'll simply say master equal to Cloud Pandit equal to 978. You see, this particular delimiter will be applied between all the columns. Okay, between these two we have a equal to, between these two we have a this equal to. But if in this concat you don't have such type of option. If you have multiple columns, every time you need to put okay lit equal to, again between these two columns again you need to use one more lit and you need to put equal to. So there is no delimiter here like this one white space. If you use this particular first argument, this first argument is a delimiter. This delimiter will be applied between every two columns, between every two columns. Now come here. This is a description again. Okay, so this description is basically tells you. See, this time I'm saying credit type. Credit type is a master. Card is with credit name. Okay, that is what will happen. Now you say it's with this. See, master card is with Cloud Pandit, Visa card is with Cloud Pandit. Some like a delimiter I have given. This will be, this entire text will be available between these two columns. Next, come here. With the column, there is the discount. Okay, I'm just applying the discount. When credit type is, see on this result, not on this result. Where is this? I'm applying concat ws. Let's say this one. You just take the latest data, df underscore concat ws1. Okay, on this I'm saying with the column discount column I'm adding. Okay, for this data I'm adding discount column. How I'm calculating data for this discount column is, if the card type, if the credit type is master, see the credit type is master, give 5% discount. When credit type is Visa, okay, then give 6%, otherwise give 7%. Let's exclude this and see. Okay, 5%, 6%, 6%, 5%, 6%, 5%, 6%, you're getting all this. It's okay. Next, come down. You see here from PySpark to SQL functions. Here you see master Visa, but Visa is the capital. What will happen when we have a capital V? This is not available. 1 second. See now null. Why null value came here? Because this is a small Visa, capital here small V. Here we have a capital V. That is the reason why this is getting failed. Okay, that condition is failed and it went to the otherwise default condition. You understood?
Yes, Malay.
Any questions, friends? Anybody is having any questions? Okay, fine. So yeah, that's all for today. So let me just stop the recording.